The world is in the midst of what may be a monumental and devastating wildfire season. Before major news outlets arrive, before official damage assessments are published, there's a good chance that clues about that fire that started in your area are already available online. Everything you'll see in this video can be done with free or open access tools. Here's how investigators at Bellingcat can build an evidence-based picture of what's happening as a wildfire unfolds. If you're in the US, you might be able to track first the emergency service responses to a fire. Applications such as PulsePoint and Watch Duty aggregate emergency dispatch information from participating agencies and can provide some of the earliest public indications that an incident is underway. Local alert systems and community reporting apps may also begin showing smoke reports before media outlets cover the event. Scanner platforms such as Broadcastify provide access to many publicly available fire, EMS, and emergency service radio channels. Radio traffic can reveal information that may not appear elsewhere for hours. You may hear requests for additional engines, reports of changing fire behavior, road closures and evacuations, aircraft deployment and medical emergencies, or declarations that a fire has jumped containment lines. One of the most important skills when listening is maintaining a log. Every transmission should be treated as a timestamp. As the incident develops, these observations help reconstruct what responders were seeing on the ground in real time. But radio traffic should always be verified through additional sources whenever possible. Dispatch information can be incomplete, preliminary, or later corrected. In some areas of the US, you can also monitor live fire and traffic cameras, for example here in California and here for the whole of the West Coast. This is easier in the United States, where platforms provide emergency response information all in one place. In Europe, equivalent information is often more fragmented. Emergency radio traffic is less commonly available to the public, but regional fire and forestry services often have available cameras, and the European Forest Fire Information System, which generates wildfire maps automatically across Europe, North Africa, and the Middle East, can also be useful. Satellites continuously scan the Earth for thermal anomalies, heat signatures that may indicate active fires, but they only spot fires large enough to be seen from space. Major wildfires often register on this scale. One of the tools you can use to see these registered thermal anomalies is NASA's Fire Information for Resource Management System, or FIRMS. Each red-marked hotspot on the map represents a satellite detection. FIRMS also employs a color classification system to show how long ago an active fire was detected, which can help to pinpoint the potential starting point of a fire. The lighter the color, the longer it's been since it was first detected. But think of these points as clues rather than proof. A hotspot doesn't automatically mean a wildfire. It could be industrial activity, a controlled burn, or even be an error. Studying a range of satellite imagery can help us. In short, different satellites reveal different details. Optical imagery shows smoke, burn scars, and landscape changes. Shortwave infrared imagery or false color imagery can help reveal active burning areas that may be difficult to see in standard color imagery. By comparing images from different dates, we can begin constructing a timeline. This approach was used by Bellingcat researchers when analyzing large fires in one of Africa's largest nature reserves, Namibia's Etosha National Park, last year. By comparing satellite imagery across several days, we tracked the expansion of burned areas and assessed how much of the reserve had been affected. Within a timeline, we want to know when was the earliest fire detected, how did it spread, when did authorities respond, what happened afterward. To answer those questions, we combine a variety of resources: satellite imagery, government statements, news reports, weather observations, and local eyewitness accounts. And each source becomes a timestamp. When multiple sources align, confidence increases. Satellites such as Landsat and Sentinel-2 can help us understand the scale of the damage, revealing burn scars and changes to the landscape. These images show the area around Capo San Vito in Sicily before and after a wildfire in July 2025. First, we're looking at true color imagery, roughly what you'd see from an aeroplane window. You can spot some scorched ground on the eastern side of the peninsula, but it's difficult to judge the full extent of the fire. Now compare that with these false color images. Sentinel-2 captures wavelengths of light beyond what the human eye can see, allowing us to highlight the difference between healthy vegetation and burned land. Here, healthy vegetation appears green, while burned areas appear red, making the fire's footprint much easier to identify. Within this area lies the Zingaro Nature Reserve. Following the wildfire in late July 2025, we found that more than 95% of the reserve had burned. Here's how we worked that out. Using Copernicus browser, we identified the last clear satellite image before the fire and the first image showing the full burn scar. We then generated a burn severity map using the normalized burn ratio, or NBR, which highlights burned areas more precisely than in standard imagery. Next, we imported that map into QGIS and overlaid protected area boundaries from Protected Planet, a global database of protected areas. Applying a simple threshold allowed us to separate burned and unburnt land. We then used QGIS to count the number of burned pixels within the reserve boundary. Dividing the burned pixels by the total number of pixels showed that more than 95% of the Zingaro Nature Reserve have been affected by the wildfire. If you'd like to try this analysis yourself, we've linked a step-by-step guide on our website. Weather data can help explain why a fire moved in a particular direction also. In the Etosha investigation, weather observations were compared against the observed spread pattern, helping researchers determine whether the movement of the fire matched prevailing wind conditions. If the fire expands northeast and the wind is blowing northeast, that supports the observed timeline. Whenever a wildfire becomes major news, images begin circulating online of the fires and their aftermath. Some are authentic, some are old, and some come from different locations entirely. We need to identify where and when these images were taken. We look for identifying features that are likely to be somewhat permanent in the surroundings, like landmarks, roads, mountains, buildings, vegetation, waterholes, and even termite mounds that can take years to form. In the Etosha investigation, people online were challenging the authenticity of a widely shared photograph of a burnt elephant, reportedly taken on the reserve. Bellingcat researchers compared the image with previously published footage from the area and matched environmental features like termite mounds to geolocate the image. Wildfires are among the most visible events on Earth. They leave traces in satellite imagery, they generate eyewitness reports, they reshape landscapes, and increasingly, they can be studied using publicly available information. The challenge isn't finding the information, it's connecting it. When done carefully, anyone can move beyond simply watching a wildfire happen and start to begin understanding it. Find more guidance on monitoring environmental damage at bellingcat.com.